Good morning, good afternoon, and good evening, everyone. Thanks for joining us today in this Refinitiv and Google Cloud webinar, where we'll be covering how to use Google Cloud BigQuery to build and backtest trading strategies using tick history. My name is Catalina Vasquez. I head up the historical data business here at Refinitiv, and I will be your host today. I'm honored to introduce our speakers today. We've got Roshak Lamba from Google Cloud. He is an industry architect in capital markets. Thanks for joining us. And Rakesh Singh, who is a product manager for tick history at Refinitiv. Before we begin, let's cover a few housekeeping items. At the bottom of the screen, you will find multiple widgets for you to use. They're all resizable and movable, so feel free to move them around and to get the most out of the experience and the screen space, most importantly. If you have any questions during the webcast, please submit them through the Q&A widget, and we'll try to answer those as we go along through the session. But please know that we do capture all questions, and we will do our best to answer them throughout. But if not, these will be covered in the Q&A panel at the end. We will be using an interactive polling today, so please do participate, take your time. We will actually be sharing the first polling question in a second. It will pop up in one of these widgets in your screen. And make sure also to check out at the end the resource lists that we will be sharing. Please download any materials that you may find useful from that. We put them together especially for this session. And you can also find more about the speakers via the speakers bio widget. And just some technical aspects, and I'll be done with the housekeeping, for a better viewing experience, make sure that you know any programs or browser sessions running in the background that will help conserve your bandwidth. And please make sure that your computer speakers or headset volume is turned up, because the audio is running through the computer. So I guess if you can hear me today, then that means that we're all good. If you ever see that the slides are not refreshing, just make sure that you refresh your browser. Finally, we will be having a short survey at the end. Please make sure to complete that. We'd love your feedback. Right, so now onto our agenda for today. Before we start with the agenda, actually, I'm curious to find out where everyone's joining us from today. So we'll start with our first polling question. Hopefully you can now see that popping up. Tell us where you're joining us from today. Is it the United States, Canada, Europe, Middle East, somewhere else? I'm sitting here in sunny London, and we've got Roshak as well in London, and Rakesh joining us from New York. Let's see, have we got some results? There we go. So we've got a good crowd from Europe, but also an interesting number joining us from the states, from the United States and Canada. So thanks everyone. Oh, Africa as well. Great. Thanks everyone for joining us today. Now onto the agenda. So we'll give you a brief introduction of what Refinitiv tick history is, why we chose to partner with Google Cloud, and why we found BigQuery as a great asset to really transform our offering. We'll also give you an overview of BigQuery and some of its great capabilities. Roshak will be able to share those details with us. We'll also cover a demo to really showcase the scaling power of BigQuery and how it's a great match for our tick history datasets. And then we'll move on to a Q&A panel session where we'll clear out any doubts that you may have, be that content-wise, be that technical issues, technical items you want to cover. We've got a great team joining us today for that, so happy to cover all of those aspects. Right, so on to another polling question, just to make sure that we've got a good understanding of where our audience sits in terms of understanding around tick history. Tell us how familiar you are with our tick history data set, or just with tick history data, tick level data in general. I'll give you a moment to complete that. Okay, that's a couple of seconds. And I think we're ready for the answers. So we've got a a good crowd in terms of a good mix, but we've got some beginners. So welcome to the beginners. Hopefully you find this insightful and useful. But then we've also got some more advanced levels. So hopefully you will also find this session very interesting, because we will be covering a new aspect, essentially how to make sure that you can take the most out of this data set by leveraging some of the great tools that BigQuery offers, right? So on to just a quick refresher on what tick history is, what the problem statement actually is, and why we chose to partner with Google. So let's begin with the problem statement. So for every dollar that is spent on financial market data, there are an additional 8 that are spent on processing, storing, and transforming this data set even before the data can be analyzed. So why wouldn't it be great if we could actually change this around and change things so that we can enable our users to not only access this data in a much faster and quicker way, but also leverage cloud capabilities and reduce this additional spend that goes in to activities that actually don't create value, but effectively only just gets you ready for that analysis, right? So that's what the biggest reason why we thought, okay, let's look into how we can transform our offering, right? So what is Refinitiv tick history? Refinitiv tick history is our historical data archive, which carries both level 1, level 2, and what we call level 3 data. So full market depth as well. We carry over 500 exchanges plus specialist data sets. So it's not only just exchange traded instruments, but also we carry broker data, we carry OTC content effectively. So it allows you to analyze and look into data all the way back to 1996. Our archive is about 6 petabytes compressed and held and replicated in different locations. So we're talking about petabytes worth of data. It is a significantly big archive, as you can already see. And essentially, what would happen in the past is clients would be storing this data on-prem or even in the cloud and paying for this storage of this data set that everyone has the same copy of this same data set in their own premises, right? We're talking tick level data. So every day, you need to, of course, allocate resources to manage and to be able to keep up with the rate at which this archive would be growing daily, right? We're looking at least 4 terabytes worth of data added daily to this archive. So all of these resources being allocated to just maintaining this golden data source that everyone is using. So is there any technology out there that we could use to ensure that we've got that data set in one place, we've got that data stored once, and everyone can access and make use of this data without having to deal with managing and storing this data set? And effectively, being also able to help customers unlock the value of this data set. So from designing and backtesting new trading strategies to execution and analysis use cases where they'd be looking at minimizing slippage or analyzing then transaction cost analysis. Also complying with regulatory requirements such as algo conformance testing or again transaction cost analysis or best execution requirements. So those are just some of the kind of broad use cases where tick history data is used. Of course, both used in both buy-side and sell-side entities alike. So going to the challenges, right, when it comes to historical data, it's quite obvious that costs and volumes of data are the two items that top up the list. So effectively, what we've done with our offering of tick history in Google Cloud is enable us to not only do that lift and shift to the cloud, but actually lift, shift, and transform our offering. What does this mean? We are bringing the process to the data without moving the data around. You no longer need to download and store and manage that data set yourself. You don't have to deal with that painful ETL or extract, transform, and load challenge, which was the responsibility of the clients, right? Clients would be, end users would be pulling the data from our platform, then downloading and storing these files on their site. And now what we're enabling is the users to come directly to our Refinitiv managed project within BigQuery and access the data as and when they need, ready for query. Combining this data set with other data sets that they might have in their own instances. We're going to cover a bit of that, and how BigQuery is a great tool as well to scale these queries, and how the technology is also used at Google. And then effectively making this data query ready without moving the data around, shortening timelines, and ensuring that you have access to the data you need when you need it. So, expectations versus reality, right? Always an important point. You look at, okay, do I really want to be spending 20% of my time only just adding value and doing the research or building the models, and spending that 80% of the time cleaning, processing, transforming, and loading and making sure that I've got the right data sets? No, actually, no. And that's not what businesses want, right? You want to be able to flip this around. And today, by simplifying the process and enabling end users to forget about the ETL challenge and let Refinitiv handle that for them, we are able to flip this around, making expectations actually meet the reality, and simplifying the whole process. So just to summarize, we're saying that it's analysis-ready data of our historical archive, so removing the need for that ETL. It's on-demand compute. Basically, we are enabling end users to benefit from the power and scale of BigQuery and Google Cloud. And then it's reliable, right? Because it's backed up and replicated storage. Also, again, leveraging on the great tools that Google Cloud can provide. So removing all of these unnecessary headaches and pain points that our customers would be facing in the past by allowing end users to consume our tech history content in BigQuery. So, having said that, I think I'm now going to hand over to Roshak. Hopefully you're still there, Roshak, to walk you through a little bit more detail about BigQuery, and then get to the fun part to walk us through the demo that we've got prepared for you today. And I think there's a polling question before that. Roshak, over to you.
Thank you, Katarina. So, as Katarina mentioned, we've got a polling question to kick this off. So, the question is, how familiar are you with BigQuery and its capabilities? There are 4 answers: no knowledge, beginner level, intermediate, or advanced. So I'll give you all a couple of minutes just to put that in. Okay. So looking at the results, wow. So most people have said no knowledge, and there's a little to beginner knowledge. So this is great. We're going to have a lot of fun going through a lot of interesting concepts. So firstly, let me start by telling you a bit about BigQuery. So BigQuery is as Katarina mentioned, we've got petabytes of data of tick history in BigQuery. But BigQuery is an exabyte scale storage and allows queries at petabyte scale. And I'll go through some queries that our clients have run previously and how the performance works. But before I do that, let me take you through the journey of Google. So BigQuery is actually an externalization of a technology that we've been building in-house at Google since 2008. We call it Dremel. So as you know, Google is a data company at heart. And we have over 9 years. So we have over 9+ services that have over 1 billion monthly active users in Google. Apologies, I'm just having some challenges shifting through this. Bear with me. Yes. So we have 9+ services that have over 1 billion monthly active users. So we needed something where we could store all this activity that was going on. So we needed something where we could pull out data about user activity, search data, such that we could train our machine learning models and create better insights into these products and make them more viable. Now, in order to do that, we endeavored on that project as part of Dremel. But for context, we basically receive trillions of data points totaling petabytes and exabytes of data, which need to be accessed by Google employees. So we have 100,000 employees all needing to access exabytes of data, and we need them to be optimal and find insights from that data. So the way we solved it was we created this data warehouse where all of the data sits in one data warehouse for all of this structure, and a single data warehouse that's accessible to everyone. So all the employees can access this one data warehouse to get whatever insights they need at large scale. So we solved it as a horizontally scaled problem. And everyone, so to give some perspective, if anyone who submits a query, whether it's a SQL query or done through code through an SDK or done through your dashboard, we create a virtual cluster for every user running this query. So we have 1 million cores available on demand, which can be used, which are basically provisioned straight away as part of the query. And what makes it even more interesting is that for every query that comes in, we estimate, right size, and learn over time the processing power that you need to run that optimally. So BigQuery eliminates the need for system engineering, data analysis workflows, so you can focus on data analysis altogether. We seamlessly deploy, maintain, and upgrade your database with none of the operations work left for you. So just upload your data and run SQL. There's no cluster deployment, no virtual managed machines to worry about, no setting keys or indexes, and no software. You just run your queries. The storage and compute remain separate, and I'll go through that, which allows storage to scale to petabytes, and that's really our secret, if you need. We also have a modern data warehousing approach, and that has introduced, that's how you can get real-time analysis. You have your centralized storage for all that stuff. As I mentioned, all of Google is stored in the same data warehouse. We have security and trust involved. We've got data accessibility, and there's MI and ML that can be, ML and AI that can be carried out on it. So the value proposition of Google is that we want to help you find insights. So I'm just going to switch to the next slide. And these are the kind of queries I want to give you a perspective of. So we have one BigQuery customer who stores 250 petabytes of data. So tick history is on that path, but we've got 250 petabytes from just one customer. Another customer has run a query which has encompassed 100 trillion query rows just for one query itself. Now, BigQuery is a serverless application, and the way to think about BigQuery and its serverless model is that our value proposition is that how much time are you spending on insights so you can give customers value? And you don't want employees worrying about things like the size of the cores that you need when you're running this query, how much disk size do you need, extracting data from CSV, putting it into one table. So tick data was born for exactly this purpose. So if you think about a traditional platform, you have that entire wheel of different functions. BigQuery is a serverless-oriented technology where we look after all that stuff for you, and you just worry about running your analysis and insights on there. So tick data is all about, as you know, tick data is all about white columns. It's all about, people need to dig into data very quickly and find those insights. So that leads me on to the architecture of how we did BigQuery and how it applies for tick history. And the architecture is conceptually simple, but actually different in a number of ways from other things. So firstly, we de-link storage to compute. And that's really important because you can send as much data as you want for BigQuery, and we'll suck it up without losing any performance. So clients like Twitter, for example, or Snapchat and Spotify, Twitter sends us every single tweet, and that gets stored out into BigQuery. Snapchat, Spotify, they send us user metrics, and as we know, BigQuery, Refinitiv, they store all their tick data, in batch form into BigQuery. So we make it fast enough and available enough. We have 11 nines of durability, so your data is not going to get lost, and we also have 4 nines of availability, and that's better than any of our competitors, and one of our standout points on a data warehouse point of view. Because compute is separate to storage, we're able to run, you can basically run simple queries, or you can run very complex queries. And what we do is if you run a small simple query, we will basically, behind the scenes in our background infrastructure, we will sum up that data that requires that. So behind the scenes, we'll basically give you the relative small machine that you need, so this compute power that you need to basically calculate that, generate that analysis, and give it back to you. And we take that because of heuristics that we capture at the back end. And we co-locate these compute machines to your data as close as we can. So we have 5 to 7K machines here and there. If you run the BigQuery, we can pull out whatever machines we need or service needs for core computation point of view, and we can basically carry out that computation by extracting the data as to where it's located and things. So that gives you incredible scaling. It's kind of like having every user having their own data warehouse. So if you're querying BigQuery, it doesn't matter how many people are querying it because we've separated as part of the structure. We have a petabit network between the storage and the compute, and all of that in the mesh in the middle of it is a distributed memory shuffle tier, which is one of our key technologies in this space. So moving on, the other aspect that I want to talk about is BigQuery ML for predictive analysis. So ML, as we know, is quite a challenging task when you have to build out an entire ML environment. You need data engineering. You need to have ML operations involved. The nice thing with BigQuery is you can actually create models within BigQuery in SQL and run those queries. So you can create those models and then execute that model on data as it comes in and get live predictions. The screen there shows you a simple example of a little widget, which shows how simple it is to create a model and execute it. So that can be very powerful because you can do it on demand as you like with the large scale of data that you've already got with BigQuery. So with that, I'm now going to shift into a demo and give you a good indication of how this fits together with tick history. So, second. Okay. So I created this little demo, and I'll be running 4 queries today to give you a bit of an idea of the scale of things. So firstly, I'm going to just do a couple of setup items where I'm just creating a few formatting structure, but I'll be running 4 main queries. So the first query I'll be running is across the London Stock Exchange's data. I'll be looking at 1 day's worth of data, and on that 1 day's worth of data, so that's 1st of July I've chosen for 2019, and I'm looking at normalized level 2 data from LSE on that particular day. I'll be taking all the bids that we get, and I'll be bucketing them per hour. So I've got daytime and bucketing them per hour, and I'm going to be showing you the minimum and the maximum per RIC for those bid prices. So if I'll just run this query now, and what you'll find is that as the query runs, this is the job ID that was being executed, and these are all my results. And I'm going to talk about the results, but I'm going to quick off this execution stats, and I'll explain that in a minute. So what this query basically did is lets you see all the different RICs, and I've just showed the top 100, but lets you see every single RIC that's in tick history, the time bucket that I was interested in caring about, and the maximum and the minimum bid in that bucket per hour across the entire day for every single RIC on the London Stock Exchange that was traded that day as part of our normalized structure that's available in BigQuery. I'm now running another query where I'm actually getting heuristic statistics from our information schema services to basically explain and show what happened behind the scenes there. So the query I ran right away, which was for one day's worth of data, took me 2 seconds. It took me 2 seconds, but behind the scenes, it needed 1 minute worth of compute time. So that was how many servers. So we basically took that query that he gave us, we created a compute at the back of it, we ran that query across and scaled it out across a large number of data points. And this is for bid prices. Then we bucketed them, we aggregated that, we gave that back to you within 2 seconds. But that required 1 minute of compute time. That's roughly 42x speed up compared to 2 seconds and 1 minute. And the size of what we queried just there in that 2 seconds was 62.7 million rows, and it was 2 gigabytes of data. Now let me do the same query, but this time let me do it over a month. So 1st of July to the 31st of July. And I'm going to kick this query off. And again, I'm taking all the thing, but this time I'm bucketing it based on minute. So I'm going, previously I did it based on millis. Previously I did it based on hour. This time I'm going even deeper into minute to just give it a bit of perspective. So that query is run. I'll now just run the execution stats. So this basically is pulling out metadata from our service, and that gives me the computation details that I want to show you around how long did it take my query to run versus how long did it take compute time to run. So all those aspects and how much data was actually scanned, which is all stored within our metadata tables of BigQuery. So these are my execution stats that I'm pulling out, and this will execute in just a couple more seconds. But as it goes along, I want you to see that the difference was simply, I took 1 month worth of data. In the first query, I took 1 day's worth of data. Now I've taken 1 month worth of data. My execution stats is now completed. Now I'm just going to demonstrate it here. So we did the query in roughly 9 seconds. It took me 1 hour of compute time to basically run down 1 hour worth of cores that we had. That was a 716x speed up compared to previously. And the rows that we scanned were 1.4 billion rows in that 9 seconds, and we scanned 45.2 gigabytes in that 9 seconds. So now we've done it for a day, we've done it for a month. Let's now look at doing it for 6 months worth of data, and we're going to group it by day. So date time by day. And again, looking at the bid price and the minimum bid price and maximum bid price, and basically it's a candlestick-oriented model across the entire month, and that query is just run. So now I'm going to run the execution stats for that as well, just to try to get the information about the heuristics of how that executed. And you can see here what we're seeing there is the minimum and maximum bids across the entire month. And you can see some days are in different days of the month. So sorry, this was for 6 months. So across 6 months, we run this from 1st of July to the 31st of December 2019. And this is, this query is basically ran in a few seconds as well. And we'll see the results of it in just a few minutes, just a few seconds, which are being aggregated as part of the analysis from the metadata. But you can see there's a lot of execution there. And if I show you what the heuristics were in real time, this should have taken 3 hours of compute time. We did it in 8 seconds, and that was a 1,643x speed up. So we scanned 9.1 billion rows this time, and that was 286.7 gigabytes worth of data. We've now looked at 6 months. So now let's look at 5 years worth of data. So this is from 1st of January 2015 to 1st of January 2020. I'm looking at all of London Stock Exchange's tick data normalized, and it's basically every single RIC tick that has been, it's been part of the order book. I'm looking at all the bids here, and I'm analyzing it at a very large volume size, and you'll see how big that volume was. And our query is still going. It's about, we're into 26 seconds right now, but we're analyzing, close to a whole month's a large volume, almost the same amount of volume that Refinitiv basically captures and stores every day across the board. And this is the entire data that they've captured across the day. That same kind of volume is equivalent to about 5 years worth of LSE data, over 5 years worth of data on the level 2 table, normalized level 2 table. So I'll let that query run, and you can see the minimum size and the bid ask size. As the query runs, and there's just a few more seconds left, we will see soon, I'll run the execution stats, but what you'll see soon is that it will take roughly just over a minute to run this query. And the query would have used 2 days worth of compute time. So analyzing 5 years worth of data from bids would have taken roughly 2 days of compute time. So my rows have just come back, my query just finished. It was just over a minute. I'm now going to run the heuristics, i.e. the analysis on the table. But these results will effectively show the same data, which is I've just scanned 77.6 billion rows in that just over a minute query, and that scanned 2.6 terabytes of data. So 2.6 terabytes of data in just over a minute would have actually probably taken 2 days of compute time. So 2.8 days of compute time was actually used under this hood behind BigQuery. We just scaled it out horizontally. And that's actually a very, very powerful stat. So my heuristics query is still just finished, and I'll just show my results just now. And yeah, effectively my results are roughly the same. But that's a 1,952x speed up that you get by running things on BigQuery. Now, you've seen all these stats. So I'm going to run some more wider stats across what has happened across the analysis. And I want to show you a bit of a plot of how this looks. So we talk about compute time, and the other term we use is human time. So human time is all about data about how long you waited for. So I waited for a minute, I waited for 10 seconds, 5 seconds. Compute time is about how much time was taken by the servers behind the scenes as part of BigQuery infrastructure. And when I've just captured some more heuristics, and now I'm going to plot it using matplotlib. And this is my result. So what you can see here is, the x-axis here is showing you the size of the data. So as I went into petabytes, roughly 8 terabytes of data that I was kind of analyzing, I have started to, you can see the blue line is my line which tells me about compute. So as I was starting to do more and more compute, I was basically seeing my compute power just going up and up and up linearly fashion. But the human eye, the results you got in front of you on that screen there was staying roughly constant. And that's really the key and power of BigQuery, because what it shows you is that as you execute more and more longer and longer compute, the harder and more difficult queries you throw at BigQuery, the faster the results you get. So I want to just let you see what these results look like again in parallel side by side, so you can kind of get an idea. I'm just rerunning all 4 of these, so you get to see their results. And what you can see here is that when we were scanning 62 million rows, we did it in 2 seconds, 1.4 billion in 9 seconds, 9 billion, we did it in 8 seconds, 77 billion, we did it in about a minute. And that is illustrated in the chart there. So the harder and longer and the bigger the queries they are, the faster the speed ups you'll actually retrieve. And what's impressive is that even small queries, as I was explaining, even the smallest queries that you run, they will run optimally as well, because we dedicate cores based on the size of the query, based on the heuristics that we extract on how complex it's likely to be. And because we know what queries have been run, where the data is stored, we can optimize it. And that's what we're doing internally. So when you run things in BigQuery, and that's the advantage of tick history, is that by having all the data there in tick history and you're doing those queries, we're behind the scenes optimizing and managing it so that you're able to access the data in the most efficient and fastest possible way, and you're getting the results. And Refinitiv is responsible in storing that data on a batch-oriented fashion. So that concludes my demo. That concludes my talk. I hope that gave you a good understanding of BigQuery and how it's used in tick history, which I just showed you there. And I'd happy to share these results. And if you wanted to have any questions, I'd be happy to answer those too. So with that, I'll hand back to you, Catalina. And I'm going to end my screen share now. Thank you.
Thanks very much, Roshak. I can see there's some questions coming through the chat. So probably a good time to then actually kick off the Q&A panel. We'll be addressing questions coming through the chat, so please make sure to pop those in as we go along, and we'll do our best to get those answered. So do I have then Roshak and Rakesh? Yes?
Yes.
Hello, Rakesh, do you want to just quickly introduce yourself to the audience?
Absolutely. Thank you. Hello, everyone. My name is Rakesh Singh. I'm a product manager for tick history and time series offering at Refinitiv. I'm currently leading the delivery of managed tick data services in Google, and pretty excited to be a part of the panel and look forward to our discussions.
Thank you very much. Thanks for joining us. So I'll start with one question I can see here coming through the chat. I think this is probably directed to you, Roshak. Is there any point at which you would run into data limits? And maybe you want to share with the audience a bit more about how BigQuery works in the background and some additional things that end users can do to ensure they don't encounter those limits.
Yeah. I would say it's very unlikely for you to run into limits. I mean, as I said, BigQuery is an exabyte storage database, and you can run queries at petabyte scale. And as I said, one of the largest customers uses, large number of petabytes of storage. We as Google is a large data company. We have exabytes of data that we query, and this is the technology we use to query that on a day in, day out. So under the hood, we are constantly improving the service and technology. So you're unlikely, unless you have more data than Google, and unless you're really hitting, doing something a little different to us, you're unlikely to hit any sort of limit as required. But if there's any specific case that you'd like me to talk about, I'm happy to. But there shouldn't be any reason why you would hit that limit.
Yeah, and to answer that from Refinitiv standpoint, at the peak of COVID, we saw nearly 140 billion messages being collected by Refinitiv on a daily basis. And our infrastructure is designed to not only handle the day-to-day velocity and volume of messages that you observe in the market, but also volatilities due to COVID and due to the announcement of vaccine. Yesterday, we saw a lot of volatility, etc. So even our infrastructure from a collection standpoint is very robust to ensure whatever happens in the market, we're going to be capturing everything in our tick history engines and playing it out and giving access to our customers to interact with our data sets.
That's a very important point that you raised, Rakesh, especially in the current environment. Another question actually coming in the chat that you might be well placed to answer is, what is the delay in terms of the data made available? And do you have both trade and quote data available on tick history?
All right, so let me take the first question first, Catalina. So tick history, as we all know, is not a real-time streaming service. It's a historical data service. We make current day's tick data available in our offering few hours after market close. So you can call it as an end-of-day data service, so to speak. To your other question around trades and quotes, I think you covered this at the start of the presentation, right? Where tick history carries level 1, level 2, and level 3 data. And a lot of us, try to, limit tick history offering to a time and sales or a TAS offering or a trades and quotes offering, but tick history is a lot more. So if you're talking about level 1 data sets, you're going to have trades, obviously, you're going to have the best quotes, you're going to have trade cancellations and corrections. And over a period of time, you're seeing a lot of emphasis on auctions data. So we have periodic auctions, we have scheduled auctions, and things like that. And obviously, you have instrument phases and market phases that tell you if a stock has been trade halted or what phase in the market a given trading is going on, whether it's in pre-trading or regular trading, auctions, etc. So we have all of these content sets in our offering, what we call as market price. We also have limited level 2 data, or L2, where we capture bids and asks, and we aggregate the quotes at a given price level. So if you talk about the highest bid price, it's going to be the first level of bid, and it's going to be sequentially arranged in hierarchy, and the number of levels that we support in our offering varies on a per venue basis. In our collections, we also have full order book data that we are looking to expose in 2021 in our GCP offering as well.
Thank you. That's very important to highlight. Roshak, another question for you. Can you visualize output from a query with libraries from other languages? Can you maybe expand a bit more on that?
Yes, we can. So the BigQuery, so you can run those queries from APIs through SDKs. I need to look up what are the different languages that are supported. I can't remember at the top of my mind, but I can come back to you. But there's definitely, you can run it in Python and Java. So I believe you can do it in C#, Go, Java, Node.js, PHP, Python, and Ruby. And these are your languages that you can directly use the client API libraries to query BigQuery on.
Perfect, thank you. I guess a question, Rakesh, for you in terms of content. How are corporate actions dealt with historically by Refinitiv? So effectively, do you first carry corporate actions, and how does that work? And maybe also paired with that, do you offer universal identifiers such as ISIN, QSIP, CDOS, and other references into history?
All right, so let me take the corporate actions questions. Yes, we absolutely provide correct data or corporate actions data via tick history. Why do our clients use corporate actions data as multiple use cases? So if, for example, someone is looking to retroactively adjust time series, then we provide an adjustment factor with any event that happens to impact the pricing and the volume history of a company. So we do provide adjustment factors, and in our pricing data, we do not adjust our content, right? Because a lot of our use cases, let's say if someone's trying to backtest their trading strategies, or if you're doing a transaction cost analytics, for example, you want to see prices exactly the way it was in the market, without any adjustment, without any manipulation, etc. So tick history pricing data remains unadjusted throughout history, but we do supply adjustment factors and other corporate action events that a customer can use to retroactively adjust the prices. And the other use cases of corporate actions data, let's say if you want to tie certain price movements for a given stock and try to relate it with an event in the market that would justify why a price has sharply increased or fallen down, etc., then you could also use our corporate actions data where we have dividend announcements, bonus announcements, etc. And whenever these events were announced, you can try to tie back these announcements with the price movements in the market. And in financial markets, for a very long time, there is a hypothesis that has been floated, which is efficient market hypothesis. Essentially means at any point in time, the price of an asset is accommodative of all available information, right? So if, again, tying back to the example of trying to relate price movements with a certain event, we also provide with our corporate actions data earnings content sets. So let's say if you're investing or if you're trading on value stocks or penny stocks, etc., which are very sensitive to earnings announcement, and if a company happens to have outperformed whatever the predictions were, that would certainly have an impact on the stock prices, and you can tie back these two events together using our corporate actions data. To your other question, Catalina, whether we have universal identifiers, we absolutely do. So when it comes to our reference data coverage, we have certain facts at an organization level that helps you identify what a RIC code. RIC is Refinitiv instrument code, right? And if you want to cross-map a RIC to an organization, you can do that. We also provide an issue-level identifier, so things like ICE and CUSIP CDOLs. You can cross-map these universal identifiers with our RIC symbologies, and we also provide court-level identifiers, so parent or organization-level, instrument-level, as well as court-level identifiers, plus some very basic vanilla terms and conditions that is part of our offering that our customers can use to cross-map and make sense of our data, which is keyed off of our RIC symbologies.
Thank you very much for covering both questions. I guess there are some questions around commercials and how these are structured. I'd mentioned one of the things actually is the good thing about BigQuery is how it splits. I think Roshan covered a little bit of this earlier, how it splits storage and compute. Roshan, do you want to maybe explain a bit more in terms of how it works for clients, just a real life example, and then maybe Rakesh, you can also chime in from the experiences that we're having with clients.
Yeah, sure, Catalina, thank you. So to give perspective, Refinitiv are the owners of the data. So they provide the licensing of this data. They store all this data into BigQuery as part of the tick history offering. And any client who wants to use this data can come. So in Google Cloud, you have your own projects. So there's an organization structure, your organization folder and projects. And within a project, you can query, and provided you have access to the BigQuery data and the views, which Refinitiv own and provide, you can query that data, and that whenever you query that data, you're only charged for what you're querying. And whenever you query anything in BigQuery, before you can do that query, you can ask BigQuery to tell you how much data you're about to scan and how much it's going to cost you, right? So there's that computation cost, which you'll know upfront when you're querying that data. But you only pay for what you use and what you query. And what you have access to query, that is something you go to Refinitiv on because you need to have the license to access that data and query it. But Google Cloud makes it super easy from your own project, from your own organization structure to query it as you please and seamlessly work as part of your organization. Over to you, Rakesh.
Yeah, thank you, Roshan. So if time is money, and I think at the start, Catalina and Roshan defined very well some of the benefits of this combined offering between Refinitiv and Google, right? So if time is money, then let's take an example of Opera data on a daily basis. You have over 35 gigs of content, and it takes you hours. If you're looking at a standard flat file delivery, then it would take you hours to pull the data from our systems back into your own applications, transform it, decompress it, et cetera. But in BigQuery, with Tick Data and BigQuery, you can start firing the queries on the fly. You do not have to obviously be concerned about any of the boring aspects of data management, which is entirely looked after by Refinitiv, and obviously Google is looking after the infrastructure.
Great, thank you. There's another question around BigQuery supporting time joins. So if I have a bunch of trades and I want to know the prevailing market price at that time of those trades, how does that work? And I open it up to both of you, whoever want to take that one first.
Maybe I can. So it's essentially defining the point in time that you need the transactions or the transactions that you're interested in, define what instruments you're interested in, and you can essentially write an SQL query that pulls those transactions of your interest.
Thank you. There's also quite a few questions around effectively the update frequency of the data. I think we covered that earlier in terms of this being a T+1 offering. Rakesh, is there anything you might want to add on your end?
Not much, Kathleen. I think there are exceptions where the data has to be delayed by beyond a couple of hours, as is the case with the standard venues, but those are exceptions, and such exceptions are very few. Yeah.
Thank you. And then another question, this one's for Roshan. Can I run BigQuery and then save back output datasets to a local machine?
Yes. Once you run the query, the data returned is for you. So however you decide to store it makes sense for you. As we said, BigQuery works really well as an analytics tool. So you can connect it up to the likes of Looker, for example, where you can visualize and analyze this data and deep dive as required. We don't really see many use cases where people pull out the data and then store it and then do other things with it, because the idea is that the performance you get from just querying the data, and even the cost of querying the data and accessing it, is so optimal that for you to pull it out, store it in your own database warehouse, and then do multiple other queries, you'll actually find you're being restricted to some form. So that the way we do it in Google is we always just query the same data warehouse all the time, because as I said, it's designed for scale. So wherever you query it, each individual, thinking about it as every developer has its own warehouse, data warehouse. That's kind of how it's designed, where each one who runs something runs it with a job, which queries the data, extracts it, and does some kind of intelligence analytics on top.
Great, thank you very much. I think there's a comment around, looking at KX or other time series database offerings. How does BigQuery compare? And I think we've got some really good use cases of clients actually looking at optimizing their use of such resources, leveraging BigQuery as a great tool to run some of the workloads in cloud. Do you both Rakesh and Roshan maybe want to comment a bit more on this just generally?
Roshan, you first.
No, absolutely. Look, the thing with KDB is, and I used KDB in my early careers at Morgan Stanley, is that it's a vertically designed architecture. And what KX have done is made it horizontally scaled. So it's a very, very great product and great offering. You got to remember, we've solved the problem in a very different way. It's a very unique proposition. We manage huge exabytes of data which can be queried, with petabytes of data within seconds, right? That's our offering here, and it's a completely different architecture, right? So this architecture is about having, separating compute from storage, optimizing it massively with a distribution layer and having a petabit network. So the architectures are completely different. And we're very proud of. I'm not going to talk about profiling, and I'm not sure how they compare around different comparison aspects, but there are different architectures. They solve similar kind of problems. And yeah, I just encourage you to review online and see what the comparable differences are. But KDB started as a single vertical database, and Wix have massively scaled it out.
Right, and I don't think I can add beyond that. Yeah.
That's all right. I think we answered the question. Thank you very much. There's just one final question, and I think we're almost running short of time. So I think there's a question around tutorials and additional materials. I'll direct you all to our developer portal on my Refinitiv. There's a whole host of resources there, and we'll also make our details available if there's anything in particular, any questions you want to direct to us, anything that you're struggling with regards to history, just generally, or we want to hear a bit more about BigQuery, our details will be made available, and you can always reach out. So just thank you very much, Roshak and Rakesh, both for joining us today. I think just one more thing I wanted to highlight before we go. Refinitiv has actually just launched a new research report on AI and machine learning in finance. This is based on hundreds of interviews that have been conducted with data professionals worldwide. So this report provides insights on different key areas. You're seeing them on the screen at the moment. So strategy, talent, tech, the barriers to talent and tech, and the disruption that both of these things are causing in financial services. You can access this report, of course, free of charge. You can find the link in the resources section. So feel free to download and skim through this report, which is very insightful indeed. So with that, I'll say thank you very much again for joining us today. It's been great having you. Hope you enjoyed hearing a bit more about BigQuery and Refinitiv tech history. Thanks again, Roshak and Rakesh, for joining us today. And I hope you enjoyed the session. And thanks for tuning in.
Thank you.